joining me for this session. And then we're going to see today's problem statement, which is energy consumption prediction in buildings, which contributes to 38% of generation of greenhouse gas emission, which is one of the predominant factors. And then we also have introduction to oneAPI, and I'll be covering different toolkits for developers and scientists. And then we'll be focusing on one particular toolkit, which is oneAPI Analytics Toolkit. And I'll also show you how you can improve your performance by 7x by writing 3 lines of code. You can just improve your performance 7x by using Intel's oneAPI. And then it's summary. This is going to be roughly the agenda for today's session. Coming to AI for climate change, this is one of the most important social causes today. And it is also one of the United Nations 2030 Sustainable Goals. And here, this is an article from Boston Consulting Group in the Forbes magazine, and you have multiple use cases here. So there is, it broadly falls under 4 categories. One is mitigation, the second one is adaptation and resilience, and the third one is fundamentals. So the mitigation is all about estimating how much energy will be consumed. Once we know the amount of energy which is actually required, which is the demand, if you can forecast the demand effectively, then you can find alternate sources of first components. There are several use cases which falls under mitigation category. Adaptation and resilience is more about some of the climate hazards has already happened. It could be floods, or it could be some kind of calamities has already happened. How do you use AI to overcome the calamity? So bad things have happened, and how do you overcome using AI? So those are use cases which comes under adaptation and resilience. Fundamentals is predominantly climate change has a huge impact on economy of the nations. What happens if your temperature goes really high, or if your temperature goes extremely down? So if it's going to be freezing temperature, a place which was not freezing before, all of a sudden, the area is flooded, or the temperature has dropped down to negative, and the food transportation might be difficult. A lot of things, it has a direct toll on the economy. So how do you do economic modeling with regards to climate change? That falls under the fundamentals category. So you have around 60 to 70 use cases shortlisted by Boston Consulting Group. Today's use case is going to focus on the mitigation. Under mitigation, there are a lot of use cases, but we're going to choose energy consumption prediction is one of the most important use cases in AI for climate change. Energy consumption prediction contributes to 38% of greenhouse gas emissions. So if we can, at least estimate amount of energy which is consumed in buildings, we can come up with different policies to reduce energy consumption, so come up with certain laws to ban certain components and things like that. So this is the context for various use cases. And as I said, today's use case is about estimating the energy consumption in buildings. And before we get into the use cases, I'll give a brief refresher of oneAPI. So by the time when I show it to your code, I would have repeated it a couple of times, so it'll stick to your memory. So what is oneAPI? So oneAPI is an open source specifications for dealing with various kinds of hardware. So underneath, you will be based on the kind of input which you give, scalar or input, or it could be image data or huge volumes of video data. You might have to interface with different kind of hardware underneath. So to interface with different kinds of hardware, you're coming up with an open specification, which is one fit, which can interface with different kinds of hardware. And this is an open source specification from Intel. This is a specification. You can come up with your own version of implementation of the specification, and you can contribute to oneAPI. You can go and visit the website oneapi.io, and you can also head out to the GitHub repository, where there's a lot of options for you to collaborate with the team and be an open source contributor as well. So this is about oneAPI. It's an open source specification. You have a lot of toolkits in oneAPI. So I've listed some of the toolkits there. There are a lot more toolkits out there. So each toolkit does a certain function. You have a toolkit for high performance computing. You also have a toolkit for IoT. You also have a toolkit for deep learning frameworks. And you have for rendering, which is used for higher end visualizing and all that. And you also have toolkits to deal with performance. And you have OpenVINO, which stands for Open Visual Interface for Neural Optimization. And you also have one Intel AI Analytics Toolkit. So today's focus is going to be on Intel AI Analytics Toolkit. But you can go to the website and explore about the other oneAPI toolkits available. There are a lot of courses and plenty of guides out there to help you out. Today's use case, I'm going to focus on Intel AI Analytics Toolkit. So I'm going to show you how you can improve your performance by 7x by just adding 3 lines of code. So we'll head on to Intel AI Analytics Toolkit next. So under Intel AI Analytics Toolkit, you have various libraries. And so our focus is going to be on Intel extension for scikit-learn. And we are also going to see Intel distribution of Modin. And we are going to focus on Intel distribution of Python. And you can also explore, these are things which will not be covered, but you can also explore it on your own. How to do Intel optimization of PyTorch, Intel neural compressor, model zoo. But we'll be focusing on these 3 for the use case. Today's use case is going to be a tabular data problem. So the last 3 is more relevant for it. But I'll also show you how you will do it in TensorFlow with just 1 line of code. No, at the end. We're already running out of time. And I'm just highlighting some of the features of oneAPI Analytics Toolkit. First, you can optimize your deep learning or machine learning pipeline, having a more optimized pipeline. And you also can accelerate the performance, increase in productivity. You can speed it up. But see, for this use case, it's 7x. But there are certain use cases where you can speed it up to even 30x, 40x. It depends on the amount of size of the data. So we are using a moderately sized data set so that there's no hassles in showing the demo. But there are a lot of data sets which is 1 TB, 2 TB and all. So for those kinds of data sets, you'll see a performance gain of 30x and all that. So these are some of the highlights of the features of oneAPI Analytics Toolkit. And this is a problem statement we have here. So we're going to use a WITS Datathon problem statement, which is hosted every year from Jan to February. And this year, 2022 problem statement was about estimating energy consumption in buildings. For the last 7 years, they have collected data from buildings in US, from all kinds of buildings. It's residential building, commercial buildings, warehouses, from all kinds of buildings. They have collected around 64 features. So the size, when the building was built, how many rooms the building has, and also a lot of temperature related data and all that. So the data set was put together by Climate Change AI Initiative and Lawrence Berkeley National Laboratory in collaboration with WITS Datathon Committee. I think it's from Stanford, MIT, and Harvard. And so this is a problem statement. And before getting on to the demo, I'll quickly just revisit the performance gain because of using Intel distribution of Python, Intel distribution of Modin, and using scikit-learn libraries, we were able to improve the performance by 7x. And for all these 3 things, I was just writing 1 single line of code. To my existing baseline solution, I'm just going to add 1 line of code and then improve the performance to 7x. So now we'll head on to the demo. Problem statement here, and you can learn more about who organizes the competition and all of it. It's open sourced in Kaggle, so you can find it. So the evaluation metric for this problem statement is RMSE. So this is a regression problem. This is a tabular data problem. We'll see the data set quickly. So the data set given to us as both building related features, and you also have features which are related to weather data. So if you take building related features, you have which year the building was built, which state the building is, and the facility type. Is it a commercial warehouse or a residential building? What type of building it is, and the year it was built, energy star rating. And these are building related features. And for weather related features, you have different, for 7 years, the data was collected. So what was the average temperature in January? What was the average temperature in February? So you have lots and lots of weather related features in the data set as well. So the target variable here, it's a regression problem. You're trying to predict how much of electricity is consumed in a building. So it's a regression problem. And so it's a Kaggle competition. So you have training data, you have the test data and all that. So you can see what are the files which is given to you. Now we'll head on to the code and how to solve this problem. If there are somebody who's beginner in data science, I'll also show you how to solve the problem, and then we'll head on to how to bring about an optimized solution. So this is my data set. So I have all these features here. And I have some missing values. There are few fields which are missing. Like there are few important variables, like energy star rating is one of the main indicator of how much energy is going to be consumed in your building, at least for US. I'm not sure if this concept is not there in India, but then you have energy star rating for each and every building there. So for each of these variables, we have several missing values. And we'll be dealing with these missing value, how to deal with missing values later. And we'll also see the target distribution variable. Target variable is a site EUI, which is amount of energy consumed. So it varies between 0 to 200. And so you can check out, there are a lot of numerical features here compared to categorical features. There are plenty of numerical features here. You can check out anytime you do an exploratory data analysis. You can check out, quickly do numerical variable distribution to see if there is going to be an outlier or any abnormality in the data. You can quickly do that. And then you also have categorical variables, 3 important variables, which is a state type. So this is collected from multiple states. So if you check the state 6, this is an imbalanced data because state 6 has got a lot of data points compared to the other state. And you also have frequency of building class, commercial versus residential. So this is not that imbalanced, but if you take up the facility types like, warehouse or different kinds of building, again, there's an imbalance here. So this is pretty much about what kind of data we are dealing with. For missing value imputation for a baseline solution, this is not a winning solution. We won this challenge, so you can find the winning solution if you're interested later on out of your personal interest. If you want to explore the winning solution, you can go to the discussion forum and you can check the first place solution here. And we have winning solution has to be outsourced according to Kaggle guidelines. So you can just go and check that, but I'm walking you through the baseline solution as of now. So missing value solutions, missing values, we just did a mean value imputation. And this is a baseline solution walkthrough. So you can do a label encoding for the categorical variables to convert them into numerical variables. And then I'm using hyperparameter tuning. I'm using a tool called Optuna to do hyperparameter tuning. You can use any other open source tools, or you can use the scikit-learn versions to actually do the hyperparameter tuning as well. So the model which I'm going to using here is LightGBM. And if you check out the feature importance, the building related features have got more influence on predicting the energy consumption. So the weather related features are not having that much of influence in predicting your energy consumption of buildings. So especially this variable energy star rating and the type of building it is, these have got highest influence. You can also do a SHAP values and you can find out which are the features which contribute more to the prediction. So this is roughly taking up a data set, exploring what kind of data we are dealing with, and then solving the problem using a simple LightGBM module. But I told you can improve the performance by 7x by adding just few lines of code, just 3 lines of code. That is what I'm going to show you next. So the 3 lines of code is for pre-processing, I'm going to use Modin. So Modin, you can use the normal Modin, which is without Intel distribution, and you can also use Intel distribution of Modin. So here I'm going to use the Intel distribution of Modin. For installing it, I just have to install this, type this command. So this is one line. For XGBoost, I have to install the Intel distribution of XGBoost. And then there are a few lines of code which I'll show you. The additional lines of code which you need to add is, once you install Modin, there is only one line of code which you will be adding, which is import modin.pandas as PD. So this is just a single line. This will give you 7x performance. If you just install Intel distribution of Modin, and you're just doing a pip install of any external libraries is a very simple thing. And just one line of code here, this is going to give you a 7x version. And the second, you'll have to install the Intel distribution of Python as well before this. And coming to the scikit-learn version, the lines of code which you need to write is this. So you need to first install the scikit-learn, Intel distribution of scikit-learn, and the 2 lines of code which you need to write is, to your existing baseline solution, I'm just adding this Intel distribution of scikit-learn, for which I'm just including 2 lines of code, which is from sklearn x import patch-learn, and then patch_sklearn. Afterwards, whenever I wanted to use scikit-learn libraries, I'm going to use this import statements. Once you do this, this is all you require to use Intel oneAPI Toolkit. Just few lines of code, you're doing a pip install and then importing their corresponding libraries. Everything else in baseline solution is going to be the same. I'm going to show you the performance gain in Intel DevCloud. So Intel DevCloud is a free cloud platform which is available, which you get a lot of free credits to get started. 20 minutes of time. So I've already run that and kept it ready for you. So you can run the same thing in Intel DevCloud, or if you're using Intel CPUs, you can try it out in your own laptops as well. But if you're not using Intel CPUs and if you really want to check out the performance and things like that, you can go to Intel DevCloud. And so get started with oneAPI. If you just go here, you will have to connect with Jupyter Lab. And there will be a tab which opens if you have not registered already. You will just have to give your user ID, fill in few fields, and then your account gets created. And I've already done all the setup and kept it ready because this is going to take time. So here I can show you the performance gain. So the performance gain is base model random forest. It's something around, the time taken is around 11. And without using, see, if you use Intel version of scikit-learn libraries and Modin and Intel distribution of Python and all that, the time taken was 11 milliseconds. And if I don't use it, then it's going to be around 75 milliseconds. So you get 7x performance. All I did was adding around total of 7 lines of code, which is 3 lines of pip install of the libraries and the import statements. With just these 7 lines of code, I'm able to improve the performance from speed gain of 11 milliseconds to 75 milliseconds, which is 7x improvement in your speed. And so this is about Intel oneAPI demo. And this, yeah, summary is about all of you. This is an open source specification. You can come up with your own. If you're going to have your own accelerator, you can come up with your own specification for the underlying accelerator. Implementation of the specification for the underlying accelerator. So you can add on to the GitHub repository. The website is open, oneapi.io. You can head on to that. You'll find the GitHub repositories link. You can also find all the clear documentation on how you can contribute to it and how you can be part of various oneAPI programs as well. So the last request is for all of you to join the movement and start contributing. With this, we have come to the end of the session. If you have questions, you can let me know.